All right. Solving absolute value equations is very similar to just solving a regular equation, but you have to keep something in mind. For example, when you take the absolute value of a number, it's just the distance away from 0. So it doesn't matter if it's 3 units this direction or 3 units that direction. They're both 3 units away. So you have to keep in mind that positive values work, but so do negative values. So for example, the absolute value of what gives me 25? And I just messed up when I wrote this, so I'm going to have to fix this. Here, I know what I'll do. Instead of deleting that, I will delete this. There we go. I think I was thinking square root at the time. Absolute value of what gives me 5? Well, there's actually 2 solutions that will work. The first one is 5. 5, the absolute value is 5. The absolute value of negative 5 will also give me 5. So you have to kind of keep that in the back of your mind that when you have an absolute value, you're going to have 2 solutions. Usually, not always, but many, many times. All right, so for example, the absolute value of x plus 7 is equal to 10. All right, I'm going to be looking for 2 possible solutions. So I want to know when what's inside the absolute value is going to give me a 10, and I wrote that right here. But I also want to know when what is in the absolute value gives me a negative 10, because if this is a negative 10, the absolute value gives me positive 10, and it would work. So when is x plus 7 equal to 10, and when is x plus 7 equal to negative 10? If I subtract 7 from both sides, I get 3 for one of my answers. But I don't get negative 3 for the other answer. When I subtract 7 from both sides, I get negative 17. So you have to be very, very careful. I'll show you with another example here. Okay, if other values are outside the absolute value, then you're going to have to move them first. You need to make sure that you, what's the phrase again? Isolate the absolute value. We're going to take that absolute value grouping symbol, and we're going to isolate it, meaning get everything else out of the way and over to the other side of the equal sign. Then we can start comparing our positive and negative solutions. Okay, so absolute value of 2x plus 4 is minus 7 is equal to 11. All right, the first thing I have to do is move anything that's not in the absolute value over to the other side. So I'm going to add 7 to both sides, and I get absolute value of 2x plus 4 is 18. Now I can look at this and say, all right, so this 2x plus 4 has to give me an 18, or 2x plus 4 has to give me a negative 18, so that when I take the absolute value, I get positive 18. So I wrote those over here. 2x plus 4 is 18, and 2x plus 4 is negative 18. Notice I did not change anything inside here. I just know that whatever's inside must equal 18 or negative 18 for this to work. So let's try it. Subtract 4 from both sides. I'll start with this one. The 4's cancel. I'm left with a 2x equals 14. That means 2 times x, so I'm going to divide both sides by 2. And I get x equals 7 for one of my answers. But I have a second possibility here. When I subtract 4 from both sides, again the 4's cancel, and I'm left with 2x equals negative 22. Divide by 2, and I get x is negative 11. All right, let's go crazy and throw in an extra couple something. 3 times the absolute value of x plus 5 minus 2 equals 10. Solve it like you would almost any other equation. If this was a variable, what would be the first step? We would add 2 to both sides. Here's my equal sign, so I'm going to add 2 to this side and add 2 to this side. Well, this minus 2 and plus 2 will cancel. And that leaves me the 3 times the absolute value of x plus 5 equals 12. Now what should I do? I need to get rid of this 3 because it's outside the absolute value. So I'm going to divide both sides by 3. And what happens? I get the absolute value of x plus 5 equals 4. All right, but I still have to solve. And now that I have my absolute value all by itself, I can try to solve. And I'm going to be looking for my two solutions. So I want to know, when is x plus 5 equal to 4? And when is x plus 5, equal amount of slant here, equal to negative 4? Now notice I did not change the x plus 5. I don't make it a minus. I don't ever change what's inside. I just want to know, when is this equal to 4 and when is it equal to negative 4? Also notice that when I'm writing my two equations, I don't have the absolute value anymore. I've taken care of the absolute value by writing the two equations. Those two together represent the absolute value symbols. So I don't need them again. Subtract 5 from both sides, and I get x is negative 1 for one of my solutions. Subtract 5 from both sides, and I get x is equal to negative 9. Now let's just check it and see what happens. I'll use purple. I'll plug in the negative 9. 3 times the absolute value of negative 9 plus 5. See, I'm just plugging it in right here. Minus 2 equals 10. 3 times the absolute value, negative 9 plus 5 is negative 4. What's the absolute value of negative 4? It's 4. And 12 minus 2 does equal 10, so I know it's right. You should be able to take your two answers and one at a time plug them back in and get the right solution. It should work and give you a correct value. All right, let's try one more thing. All right, same thing. I need to subtract the 5 from both sides. Anything that is outside the absolute value needs to get moved. That cancels, and I have absolute value of 2x minus 7 equals negative 3. I'm done. I don't need to set up my two equations. I don't need to go any further. Do you know why? We did talk about this in class, but I want to make sure you remember. The absolute value of 2x minus 7 could never, ever give you a negative 3. Right? Isn't absolute value always either 0 or positive? Absolute value is always a positive solution or 0. So this could never happen. The answer is no solution. Ha, trick question. But be very, very careful. Let's move this. What if I had something like this? Don't jump to no solution too quickly, because the only time you can decide that it's no solution is when you have isolated the absolute value. You get it all by itself. I have not isolated my absolute value, so I should add 5 to both sides. And when I add 5 to both sides, you will then see that there is a solution. Matter of fact, there will be 2. And I can tell that because I have an absolute value equal to a positive. I again would then just set up my two equations. When is 2x minus 7 equal to 3? And 2x minus 7 could equal negative 3. And then when you add 7 to both sides, I get 2x equals 10, x is 5, and I don't know if you can still see that in the video, but x is equal to 5. Adding 7 to both sides gives me 2x equals 4. Divide by 2, and x is 2. So in this case, the absolute value is equal to a negative. Doesn't work. No solution. In this case, the absolute value is not equal to a negative. After I move that minus 5, I find that it is equal to a positive 3, and I can then continue and solve this problem. And one last thing that I wanted to mention, when an absolute value is equal to 0, if I really wanted to, I could write x plus 6 equals 0 and x plus 6 equals negative 0. But really, what is negative 0? It's the same as 0. So what happens is whenever an absolute value is equal to 0, that's the only time you're only going to get one solution. Only one answer will work. All right, so if your absolute value equals 0, you'll have one solution. If it equals a negative number, you won't have any solutions. Otherwise, you're going to have 2. So you just need to set up your positive and negative values and solve each equation separately. And that is solving absolute value equations. Good luck.